Thank you, moderator's introduction. Committee chair and committee member and leader, good afternoon, everyone. On behalf of Everlight Chemical, I would like to welcome you here today. Today I will share our new product for the 200mm silicon wafer carbide slurry for the polishing. And 3 years ago, in 2021, Everlight launched a regenerable slurry for silicon carbide wafer substrate polishing. This year, we launched a new product for the 200mm silicon carbide wafer polishing. And this polishing slurry have a high remove rate, more than 3 times higher than the former slurry, and it's a good service quality after the final polishing. So I will share this information here. Before the information share, I will make a brief introduction of Everlight Chemical. Then I will share the information for the slurry. Yeah. Everlight was founded in 1972 and had 246 million US dollars revenue in 2023. We have 20 offices around the world, and the headquarters is in Taipei. 7 offices in mainland China, 1 office in Turkey for Middle Asia for the service, 1 in Netherlands for Europe, 1 in US. This year, a new open office in Vietnam for the Southeast service. 6 production sites around the world, 5 in Taiwan, and 1 in mainland China at Suzhou. More than 1,800 employees around the company group. Yeah, we have 5 business units for the company group. The first one is color chemicals, 40% in the revenue share. And the major product is a textile. It's for the natural fiber textile, and such as the cotton, the silk, linen, and the leathers. Yeah. The second business unit is a specialty chemical, 25% revenue share. The major product is the additive for the material to prevent the UV degradation and extending the durability. The third BU is the toner. The major product is the carbon black toner and the color toner for the laser copy machine. And the fourth is electronic chemical. 17 revenue share. The major product is the material for the consumer electronic device manufacture process, such as the photoresist and developer. And the last one is the pharmaceutical chemical division. The major product is the API for the medicine tablet and medicine solution. The API is, we always say, is the active component for the tablet. %4.5% revenue in R&D activity. 240 research staff. Almost around 200 patent grantees. Yeah, that's all. The location is Taiwan Island. We are the whole HQ is here, headquartered in Taipei, and the manufacturer site is in Taoyuan. The northwest to the Taipei, Taiwan Island. Our manufacturer site is 20 kilometers north to the airport, Taoyuan Airport, 50 kilometers south to the Hsinchu City. Yeah, so welcome to Everlight Chemical, just 20 kilometers to the airport. Yeah, to go to some information about the production application is for our life surroundings. The first one is die stub. We make a die stub to the formula to the digital printer ink, and you can design the picture by subwire and printing the picture by printer on the textile. This process can save the water more for the pollution, certain pollution for the saving water. We also provide a functional die for solar cell. This solar cell can combine with e-paper for the indoor display. So also build up the safe power system. It's always charging to the e-paper display. So we can catch the indoor light to saving the power. Another product is the P1 adhesive. It's moisture curing, so we can solvent-free. Again, it be adhesive for the functional textile. Another product is the additive for the material to prevent the UV degradation. So we can add the additive in the color paints. So to prevent the paint from the UV discoloring and yellowing. Another is the product for the consumer electronic device, such as the lithography material is a photoresist and polished slurry developer, stripper for photoresist, and the functional ink for bezel display package. The pharmaceutical is API for the medicine tablet solution. For example, is ice drop for the ice treatment, and such as the anti-glaucoma. So we believe we can make the chemistry better or our life better. So the human always say the chemistry material is sometimes to our life and to our humans. So we believe we can make chemistry better. Yeah. Let's go to the slurry information for the 200 millimeter silicon carbide wafer polishing. Yeah. So we can see the process for the wafer manufacture process. It's a traditional process. There are six stages here for the polish manufacture. It's a typical process. Here, this four process is a major for the polishing, and this two is a major mechanical force for the polishing, and the last two is like CMP, it's a mechanical and chemical force combined for the polishing process. So these four processes will take 8 hours to complete the process. And we provide a new process here. Then we try to combine these 4 processes to one processor using one slurry to save the time. And you can see the remove rate here is more than the 10 micrometer per hour. A typical process, the slurry is 3 to 6 micrometer per hour. So we improve the remove rate to the 10 micrometer per hour. And you can see for the surface roughness, after the polishing, for the final polish, you can see the good surface process, good surface roughness for its 0.06 nanometer. The RA we means the surface roughness. And so total we can say the time is 50% more the typical process. It's 8 hours short to the 4 hours. So our new product slurry has 2 advantages. The first one is the higher remove rate, so we can have a high performance. And after final polish, we can obtain the good surface roughness. And the second is permanganate free. It's a purple solution. It's a strong oxidant. So when we're using this chemical with the strong oxidant, we have to care for it because we damage our skin and damage the environmental. So we try to make our slurry without the permanganate, without the oxidant. Okay. And another extent is the peroxide, hydrogen peroxide. Yeah. So let's go to see the process window for this slurry. It's a tested result here, and the polisher is a speed fan, 36 inches diameter platform. Then the polish pad is a commercial pad. You can buy the pad from the marketing. No need from Everlight commercial pad. And the wafer is 100 millimeter. Rotation speed we fix on the 50 RPM, and the polish time is 20 minutes. And we set up the downforce pressure. 170, 200, and 230 is the downforce pressure when the polishing. So for this chart, we can see the remove rate is from the 8.6 micrometer goes to the 13.4 micrometer when the downforce pressure is from the 130 to 230. So the result is the downforce pressure is increased, the remove rate is also increased, and the important is the surface roughness. We have to keep a good surface roughness is 0.9 nanometer surface roughness is for the start polishing. Okay. So the process window, we can see if you want to the more than 10 micrometer remove rate, so the process windows are here. Another process window test is the rotation speed versus remove rate. And the polisher is the same speed fan, and the pad is the same, the commercial pad. Wafer is the same, 200 millimeter. Rotation speed, we set up the 2 conditions. One is 35 and the other is 50 RPM. And the polishing time is 20 minutes. And we fix the downforce to the pressure to the 200. So for this chart, we can see the rotation speed goes right, increase the rotation speed, and the remove rate is also increased from 10.2 to 11.2 micrometer. And also we can focus on the surface roughness. You need 0.9 nanometer. Okay. So let's go to the wafer surface inspection. It's our design process here. The two stage here. Then the first stage we say is the stock polish stage, and as we say, we see the remove rate more than 10 micrometer. And here's the polish recipe here for your reference. And we go to the fine polishing. Here, in this stage, the recipe is here. So after the fine polish, we have to check the surface roughness because the silicon carbide wafer just one side is we say the Si face, another side we say the C face. So we have to check the surface roughness. We always check the C face is a 0.06 nanometer for the roughness after the final polish. Here's we say is the AFM spectrum for inspection the surface roughness. The first one is the original without polish. The surface roughness is 4.0 nanometer. And after our new polish slurry here, the surface roughness go down to the less than 1.0 nanometer. Then this process goes to the final process. The surface roughness goes to the 0.06 nanometer. Okay, and then we take this 200 millimeter silicon carbide wafer to the candela to check to scan the surface scratch and the defect. As you can see from this map, it almost no scratch here. So we think our design, this process is good, and we can save the time to 50% for the typical, compared to the typical process. Let me to recap the main points here for the summary. The first is our new product for the stock polish slurry. They have a good high remove rate. And after final polish, it can exhibit a good surface quality. As last page, we see the check by the candela. The third is for environmental friendly. We do not add the oxygen in the slurry. So you also can save the water treatment, the water waste treatment. It is a treatment cost here. Yeah. And for the stock polishing and the fine polish stage, combine this stage, our process can save the time to 50%. Yeah. So here, if anyone need to know more information, so you can visit our booth in the whole one, the first floor. Our booth number is K2160. Yeah. And thank you for your attention.
Okay, right now the talk open question to the floor. Maybe let me ask you a question.
Yes.
In the abstract, you do mention you can reclaim the slurry to save the waste.
Yeah.
And can you talk about that a little bit?
As 3 years ago, we launched this product is the regenerable slurry. We sell the slurry to the customer, and when you using, you can collect the, as they say, the waste slurry. Yeah. Then we come back to our lab, our manufacturer. We can check the component. When we lost the component, we can add back to the component, to the slurry, and we will measure the performance. We can make the waste slurry back to the original slurry function. Yeah.
Okay.